Welcome to 4.3's Math Moment. Today students learned how to find the surface area of prisms, other prisms than just rectangular prisms and cubes. So they saw problems and shapes like this pentagonal prism and they were asked to find the surface area of that. Remember that finding the surface area of something, I always explain it to students like, I have a box that is this shape and I need to cover the box with wrapping paper. How much wrapping paper do I need? I need to be able to cover every single piece, top, bottom, every side, so no one can see what's in that present. Alright, so that's how I kind of explain to them what surface area is. You're covering every single side, even if it's a 3D shape. So to find the surface area of this pentagonal prism, it's a pentagonal prism because it has 5 sides, which is a pentagon. It's a prism because it has rectangles that are connecting the two pentagons. Alright, to find the surface area of this, we're going to have to go through a couple of steps. Alright, but the first thing to notice, and the first thing I have students do, is to write down what shapes we're working with. Well, we're working with some pentagons, and we also have rectangles on the sides. Okay, in Unit 2, they learned how to find the area of all of these shapes. Alright, so they're going to have to dust off their brain a little bit and think back to Unit 2 to remember how to find the area of a pentagon. But what I first have them do is identify, how many total pentagons do I have in this shape? Well, I have one on the top and I have one on the bottom. So I have them write that I'm working with 2 pentagons. Then I have them think, how many rectangles are you working with? Well, I have 1, 2, 3, 4, 5. I have as many rectangles as I do sides of a pentagon. A pentagon has 5 sides, so it's going to need 5 rectangles to connect it to the other pentagon. Now, this information is going to be helpful for us once we find the area of each shape. So we're going to first find the area of a rectangle. I have students look to see, okay, what rectangle am I working with and what are its dimensions. All of the rectangles are going to be the same, so if I find the area of 1, then I just get to multiply it by the 5, and I've taken care of all my rectangles. So, length times width is how I find the area of a rectangle. And in this problem, my length is 5 and my width is 4. 5 times 4, it equals 20. So now all I have to do is take 20 times 5 to find the area of all of the rectangles. 20 times 5 is 100, so then I have them write 100 off to the side to remember that is taking care of all of my rectangles, but I still have to add it in with my pentagons. So this is going to come in, we're going to use that later when we add it into the pentagon formula. Alright, so the next thing that we're going to look at is finding the area of a pentagon. In Unit 2, students learned that when you have a regular polygon, what you need to do is draw a circle in the center and make that shape into triangles. So we're actually going to use the one on the bottom today. Because if you notice, I already have a circle here that's showing my height. My height is 3 feet. I'm going to be able then to break that pentagon into triangles, and I should have 5 total triangles. 1, 2, 3, 4, 5. If I find the area of each triangle, then I'm able to find the area of the pentagon. So, the area of a triangle, the formula is base times height divided by 2. So I need to take 5 times 3 divided by 2. 5 times 3 is 15. When I divide 15 by 2, I'm going to get 7.5 or 7.5. So each triangle inside the pentagon is worth 7.5. And sometimes I have students even write that in the triangle to help them visualize and see. And you might remember if you watched this video in Unit 2 that we did that as well. Alright, so to figure out the area of the whole pentagon shape, I'm going to have to take 7.5 times 5. 5 times 5 is 25. 5 times 7 is 35 plus 2 is 37. So this whole pentagon is 37.5 feet long, or excuse me, has an area of 37.5 feet. All right, now I'm I'm not done because I have 2 total pentagons. So I have to take the area of 1 pentagon and multiply it by 2. I'm going to do this right here. We'll erase it later, just so you can see the work a little more clearly. Right? So my total for both pentagons, 1 pentagon was 37.5, but I have 2 of them, so I multiplied it by 2 to get a total of 75. This is the area of all of the rectangles. This is the area of both pentagons. I've taken care of 5 rectangles. I've taken care of 2 pentagons for a final answer of 175. My unit is feet, and I'm working with surface area, so I'm going to square my units. All right, let's go ahead and take a look at example 2. Example 2 says Tessa has 2 identical gift boxes. Find the surface area of both boxes. Well, we want students to see that yes, she does have 2 boxes, but if they're identical gift boxes, once I find the surface area of one, I can just double it to find the surface area of both boxes. I don't need to do the formula 2 separate times. So I'm going to refer back to my formula for rectangular prisms, which we learned in 4.1 and 4.2, okay? Because there are 2 of each type of face on a rectangular prism, we call it the 2 trick. All right, where we take 2 times length times width, plus 2 times length times height, plus 2 times width times height. Notice that I use each dimension 2 times, 2 heights, 2 widths, 2 lengths, and I use them each in a combination with each other where it does not repeat. I don't have the same 2 dimensions being multiplied together in any of my series there. So I know my formula is set up correctly. Now I need to identify which is the length, which here is 5. I'm going to write it over here. Which is the width, 4. And the height would be 10. Okay, we encourage students to write out which one is which if the problem identifies each one, because it will really help them when they're placing the numbers into the formula, not to mix them up or repeat when they shouldn't. So I'm going to take 2 and plug in my numbers. Length is 5 and width is 4. Length again is 5 and height is 10. Width I know is 4 and my height was 10. So now that I have all my numbers in place, I just need to multiply first what's in the parentheses. So I'm going to go through and do that quickly. 5 times 4 is 20. 5 times 10 is 50. 4 times 10 is 40. Now because this is a lot of steps, a lot of students forget to then also multiply these by 2 before adding. Some students will stop and just add 20, 50, and 40, and their answer will be wrong times 2. So we need to make sure to watch and encourage them to follow it through with those times 2s all the way to the end of the problem. So I still have to double each one. 2 times 20 was 40, 2 times 50 is 100, 2 times 40 is 80. And now is the time where I just get to add these numbers together. I've got 100 plus 80 plus 40 for a final answer of 220 centimeters. Now, remember that this problem I have 2 gift boxes. I only took care of 1 gift box, but if they're identical, that means this one is 220 as well. So to find out how much they both are, I would just need to add 220 and 220 for a final answer of 440 centimeters squared. If you have any questions about lesson 4.3, make sure to see your math teacher.